A wildlife researcher is tracking a flock of geese. The geese fly 5 kilometers due west, then turn towards the north by 50 degrees and fly another 3.5 kilometers. How far west are they of their initial position? So, the question tells us that we have a flock of geese, represented by this dot here, flying 5 kilometers west, then turning towards the north by 50 degrees and flying another 3.5 kilometers. What is asked of us is how far west are they of their initial position. So they've turned towards the north and this is where they are now. What we are asked for is how far west are they of their initial position. So we're asked to find out this length. If they would have continued west, what is the magnitude of this distance right here? So we have this angle here. If we take the cosine of that angle, which would be equal to adjacent over the hypotenuse, therefore we can find out what the adjacent magnitude is. Adjacent would be cosine of 50 into the hypotenuse, which gives us which is 0.64278 into 3.5. which is approximately 2.25. So the geese are approximately 2.25 kilometers west of their initial position. The next question asks us, what is the magnitude of their displacement? So what we are asked for here is now, how much is this right here? How far are they off from their initial position? It's not asking us east or west, it's just asking us the magnitude of the displacement. So we are asked to find out what this is. In order to do that, we need to apply two formulae. The first is we need to find out this value right here, which we can find out with the tan formula. So tan of this angle 50 degrees is equal to opposite over adjacent, which is, this is the opposite and this is the adjacent. The adjacent value we found is 2.25, so opposite would be equal to tan of 50 degrees into the adjacent, which is 1.1917 approximately into 2.25, which gives us a value of 2.68. And since this is displacement, this is in kilometers. 2.68 kilometers. So we have the value of this, and we have the value of this. Now we have to find out the value of this. By the Pythagorean Theorem, we know that hypotenuse square is equal to the sum of the squares of the lengths of the other sides of the triangle. So 5 plus 2.25 the whole square, which is the length of this side, plus 2.68 the whole squared is equal to the hypotenuse square. Now if we get those values, so this adds up to approximately 7.25, and if we square 7.25, we get 52.5625 plus 2.68 the whole square, which is approximately exactly 7.1824. We add those values together, we end up with 59.7449, which is the value of the hypotenuse square, and the hypotenuse would be the square root of this answer, which would be equal to approximately 7.73 kilometers. So this value is 7.73 kilometers. So the magnitude of their displacement is approximately 7.73 kilometers. First, we use the cosine of the angle to find out how far west they are of their initial position. Then we use the tan of the angle to find out this side of the overall triangle, and then we use the Pythagorean Theorem to find out the magnitude of their displacement. A lot of trigonometry to find out how far geese are flying.